Welcome to Homework Lib.
Given the graph of a rational function f, we want to find the domain. The domain is left and right, and it's everything that would be included in the x's. And so in interval notation, we would say, it goes from negative infinity all the way to left, but notice that vertical asymptote at x equals -3. So it's going to skip over -3. And then notice there's also a hole in the graph at x equals 2. So we have to include that as well in our domain. The range, it goes down to negative infinity along the y-axis, but then it goes up until that hole, which is at -1. So it skips over that, and then there's a horizontal asymptote at +1, and then it goes up to infinity. The vertical asymptotes are just x equals -3. Is there a hole in the graph? Yes. If so, where is it? At 2, -1. What is the horizontal asymptote? Y equals 1. Any intercepts? We have x-intercepts at 6, 0, and y-intercept at 0, -2. F of -5, if x is -5, that goes to an output of 4. For what values of x is the function equal to -3? The function is equal to -3 at an x value of -1. The intervals where it's increasing when it left to right, it's going uphill. So it's increasing actually along its whole entire domain. Same as the domain, because it's going up everywhere it exists. It is never decreasing. It's never going downhill left to right. The behavior of the graph near the vertical asymptote, you would say as x you could say it like this: as x approaches -3 from the left, f of x goes up to infinity, and as x approaches -3 from the right-hand side, the function goes down to -infinity.